In 2024, the ATLAS telescope detected something extraordinary about the interstellar object known as 3I/Atlas. And what they found inside isn't just unusual, it's absolutely terrifying. Not because it's alien technology, but because what it reveals is far more mind-bending than anything science fiction could imagine. Renowned physicist Dr. Michio Kaku has called this discovery one of the most significant findings in modern astronomy. So what exactly did we find? And why are scientists losing sleep over it? Stay with me, because what you're about to learn will change the way you look at the night sky forever. Let's rewind to October 2024. Astronomers using the ATLAS telescope system in Hawaii were doing what they do every night, scanning the skies for asteroids, comets, and anything unusual heading our way. Then something caught their attention. An object, moving fast. Really fast. But here's where it gets interesting. This wasn't just any space rock tumbling through our cosmic neighborhood. The trajectory calculations showed something shocking. This object didn't originate from our solar system. It came from interstellar space, from beyond the influence of our sun. Scientists named it 3I/ATLAS, with the I standing for interstellar. This made it only the third confirmed interstellar object ever detected passing through our solar system. The first was the famous Oumuamua in 2017. The second was Comet Borisov in 2019, and now we have 3I/ATLAS. But unlike its predecessors, 3I/ATLAS was about to reveal something completely unexpected. As telescopes around the world turned their attention to this cosmic visitor, they noticed something strange in the light spectrum bouncing off the object. The data didn't make sense. The readings suggested there was something unusual about its composition, something about its internal structure that defied easy explanation. Dr. Michio Kaku, a theoretical physicist and one of the founders of string field theory, immediately recognized the significance. In his words, when you see something that breaks the patterns we've observed for decades, you're either looking at an error in your instruments or you're looking at something that will rewrite the textbooks. The instruments weren't wrong. So what exactly did scientists discover inside 3I/ATLAS? Using advanced spectroscopy and radar imaging techniques, researchers were able to peer beneath the surface of this interstellar wanderer. What they found was a structure unlike anything we've ever seen in a natural space object. Imagine, if you will, a honeycomb, but not just any honeycomb. A three-dimensional lattice structure with cavities and chambers arranged in patterns that seem almost impossibly organized. The internal architecture showed regions of varying density, creating what scientists are calling structural anomalies that shouldn't exist in a naturally formed object. Here's why this is so unsettling. When asteroids and comets form, they do so through random collisions and gravitational accretion. They're messy, they're chaotic. They're like cosmic snowballs that have been rolling around for billions of years, picking up debris along the way. But 3I/ATLAS, its internal structure shows patterns, organization, symmetry in places where chaos should reign supreme. Dr. Kaku explains it this way. It's like finding a perfectly arranged library in the middle of a junkyard. Nature doesn't work that way by accident. Something created this structure, and we need to understand what. Now, before your mind jumps to alien spacecraft, let me be clear. Scientists aren't claiming this is artificial technology. What they're saying is potentially even more fascinating. This structure might be the result of physical processes we don't yet understand, formed under conditions so extreme and so alien to our experience that they've created something entirely new. The density variations suggest that 3I/ATLAS experienced extreme pressure and temperature differentials during its formation. We're talking about conditions that might exist near black holes in the hearts of dying stars, or in regions of space where the laws of physics operate at their most extreme limits. Now here's where things get really interesting, and frankly, a little unsettling. If 3I/ATLAS were alien technology, that would actually be the simpler explanation. We could understand it through the lens of engineering, intentional design, and purpose. Strange? Yes. Unprecedented? Absolutely. But comprehensible within our framework of understanding. But what we're actually looking at is something far more profound, and in many ways more terrifying. Evidence that the universe can create structures through natural processes that we never imagined were possible. Think about what this means. For centuries, we've built our understanding of physics, chemistry, and astronomy on observations made from our tiny corner of the cosmos. We've assumed that the rocks, ice, and minerals we see in our solar system represent the full range of what's possible in nature. 3I/ATLAS is telling us we were wrong. Dr. Kaku puts it in perspective. Every time we discover that the universe is stranger than we thought, it reminds us how much we still don't know. It's humbling and exciting and terrifying all at once. Because if we were wrong about this, what else have we been wrong about? The structure inside 3I/ATLAS suggests that somewhere out there, in the vast darkness between stars, there are regions where matter behaves in ways we've never witnessed. Where temperature, pressure, radiation, and gravitational forces combine to forge materials and structures that would seem impossible by Earth standards. And here's the truly chilling part. If objects like this can form naturally, what else is out there? What other impossible structures are drifting through interstellar space, waiting to be discovered? And what does this tell us about the true nature of the universe we inhabit? Let's dig deeper into the science. When scientists analyzed the spectroscopic data from 3I/ATLAS, they found chemical signatures that were unexpected. The object contains common elements like carbon, silicon, and iron, but they're arranged in mineral structures that are incredibly rare, even in meteorites. Some of these minerals can only form under extreme conditions. Temperatures exceeding thousands of degrees, pressures millions of times greater than Earth's atmosphere, and exposure to intense radiation fields. But here's the puzzle. These extreme formation conditions appear to have happened alongside processes that require cold temperatures and low pressure. It's like finding ice and lava rock fused together in a way that shouldn't be possible. Dr. Kaku and his colleagues have proposed several theories. Theory 1. The supernova nursery. 3I/ATLAS might have formed in the aftermath of a supernova explosion, where dying star material gets compressed and heated to unimaginable extremes before being blasted into interstellar space. The rapid cooling and compression could create these unusual structures. Theory 2. The dark matter. Interaction. Some scientists speculate that interactions with dark matter, which we know exists but don't fully understand, might be able to influence the formation of objects in ways we haven't predicted. The mysterious internal structure might be a signature of dark matter's influence. Theory 3. The rogue world fragment. Another possibility is that 3I/ATLAS is actually a fragment from a planet that was ejected from its star system, carrying with it geological structures formed under alien world conditions completely different from anything in our solar system. Each theory has its merits, and each one pushes the boundaries of our understanding. Now you might be wondering, what does a weird space rock have to do with finding alien life? Everything, actually. If the universe can create structures this complex through natural processes alone, it suggests that the cosmos is far more creative than we ever imagined. And if nature can create intricate structures in lifeless rocks, what might it be capable of when it comes to creating life itself? Dr. Kaku has long argued that life in the universe might be more common than we think, but also far stranger than we can imagine. He often says, we're looking for life as we know it, but the universe might be teeming with life as we don't know it. The discovery inside 3I/ATLAS supports this idea. It shows us that the universe has tricks up its sleeve that we never anticipated. If simple physics can create such organized complexity in a lifeless object, Imagine what it might achieve with the right chemistry and energy sources. This discovery also expands the potential habitats where life might exist. If extreme conditions can create these intricate structures, then maybe life can emerge in environments we previously dismissed as too harsh or too hostile. Perhaps life exists in the crushing depths of subsurface oceans on rogue planets. Maybe it thrives in the intense radiation fields near neutron stars. Or it could be flourishing in the cold, dark reaches of interstellar space itself, in forms so alien that we wouldn't recognize it even if we were looking right at it. The point is, 3I/ATLAS has opened our minds to possibilities we hadn't seriously considered before. Let's zoom out for a moment and look at the bigger picture. We live in an era of unprecedented discovery. In just the past few decades, we've found thousands of planets orbiting other stars. We've detected gravitational waves from colliding black holes. We've photographed the shadow of a black hole. We've landed rovers on Mars and flown a helicopter in its thin atmosphere. And now we're learning that even the simple objects drifting through space can harbor mysteries that challenge our deepest understanding of nature. Dr. Kaku often reminds us that we're living through what he calls the golden age of astronomy and physics. Every year brings new discoveries that force us to rewrite what we thought we knew. But 3I/ATLAS is special because it represents something profound. A reminder that the universe is still capable of surprising us, still capable of presenting puzzles that make our best scientists scratch their heads in wonder. The internal structure of this object is telling us a story about its birth in some distant corner of the galaxy, about the violent or exotic processes that shaped it, about its lonely journey through the void between stars for possibly millions or even billions of years before randomly intersecting with our solar system. And we just happen to be here, with our telescopes pointed at the right spot, at the right time, to catch a glimpse of this cosmic traveler as it passed through our neighborhood. Think about the odds of that. The galaxy is vast, space is mostly empty, yet this object, forged under conditions we're only beginning to understand, traveled across light years of space to give us a brief window into the unknown. Some might call it luck. Dr. Kaku calls it destiny. As he puts it, the universe wants to be understood. It keeps sending us messages in the form of phenomena and objects that push us to ask better questions and develop better theories. So, where do we go from here? Scientists are planning to use some of our most powerful instruments, including the James Webb Space Telescope, to get even more detailed observations before this object speeds away from our solar system forever. They're hoping to answer critical questions. What exactly are those internal cavities? How did they form? What can they tell us about the environment where 3I/ATLAS was born? And most importantly, are there more objects like this out there? Dr. Kaku believes that 3I/ATLAS is just the beginning. As our detection capabilities improve, we'll discover more interstellar objects passing through our solar system. Each one will be like a message in a bottle, carrying information about distant reaches of the galaxy that we can't yet visit ourselves. He's also pushing for more ambitious missions. Imagine if we could actually intercept one of these interstellar visitors with a spacecraft, take samples, and study it up close. The scientific payoff would be enormous. We could literally hold in our hands material that formed under alien conditions light years away. There are already preliminary proposals for such missions. The technology is challenging but not impossible. Within our lifetimes, we might see humanity's first mission to catch and study an interstellar object. And who knows what we'll find when we do. As 3I/ATLAS continues its journey out of our solar system and back into the depths of interstellar space, it leaves us with more questions than answers. But those questions will drive the next generation of research, inspire new missions, and eventually lead to breakthroughs we can't yet imagine. Maybe someday, decades or centuries from now, humanity will have spread throughout the solar system and beyond. We'll have unraveled the mysteries of dark matter and dark energy. What do you think is inside 3I/ATLAS? Natural formation or something else? And what other cosmic mysteries should we explore next? Let us know in the comments below and hit that like button and subscribe to the channel.